Hey folks, I'm making this very quick video, just super low tech here to go over the acid rock drainage question, just so that we can solve it in the discussion forum, okay? So follow me while I show you what I wrote on paper. Okay, so I told you it was gonna be super low tech. I just sat down with my pen moments ago and went through it. Okay, so here's Sam's answer, okay, where he said coefficients are 4, 14, 15, 4, 8, and 16. I've gone through them all, okay, and I've made sure they match. 4 on the reactant side, a product, 8, 8, 28, 28, 44, 44. I think Sam's checks out. Now, Mike, it turns out, Mike, I went through yours, and actually you wrote it wrong in your in the discussion forum. When you worked it out, you put FeOH6, and that's when you take these coefficients that you have 1, 4, 5, 1, 2, 2. If you have an OH6 here, it actually works. But if I take the exact same coefficients and I work on it with the correct formula, the FeOH3, it turns out that these two don't balance. So Mike, I think your answer is disqualified just because you actually had a typo right here in the FeOH. Now let's look at Dan's. Dan's is also good. I've gone through it, I've written, no typos, everything matches, bing, bing, bing. So it turns out we've got two good answers really. We've got Sam's good answer at the top here where everything checks out, and we've got Dan's good answer at the top. Now, that means there's really two ways to balance this equation, which is neat. Now, in real life chemistry world, I'll tell you that one of them is actually a little bit better than the other, but it's too early for you guys to really be there, but I'll explain to you why. Take a look at this. Okay, on the reactant side, the net total charge on the reactants here is 0, right? That is 0 implied 0 implied 0. So net total reactant charge is 0. Look on the product chart side. You got 8 of these, so 8 times minus 2, that's a minus 16 charge. And here's the offset, a plus 16 charge, right? So here's a minus 16 charge, plus 16 charge, offset perfectly. Now take a look here for a second at Dan's answer. Okay, here's Dan's. On his side, he's got a net charge on this side of 0. On this side, however, he's got 2 ions. He's got a pair of minus 2s, that makes a minus 4, and now he's got a plus 3. Ah, what does this tell you? A minus 4 and a plus 3. They don't cancel each other perfectly out. Okay? So you'll learn in future courses in chemistry that the charge balance also comes into play on very complicated balancing equations. For the purposes of this course, though, I would give both Sam and Dan absolutely full marks on these. They're both two good balanced equations. And Mike, I'd give you A for effort. The only problem is you had a tiny typo. You put a 6 here instead of a 3. Okay? Let me know if you think I'm on the right track with these. Okay?